Hi everyone, welcome to new video. Today we are going to discuss single element in a sorted array. What this question states is, you are given a sorted array consisting of only integers, where every element appears exactly twice, except for an element, which appears exactly once. Return the single element. A statement says the question where you are given an array, you have to return a single element which is not repeated. That's 2 here. So the answer is 2. Similarly, it's 10 here, the answer is 10. Your solution must run in O of log n. So O of log n means that states you have to use binary search. Now it's a observation based question. So let's see what might be the approaches right here. So this is one of the example test case which they had given in the elite code. So let's see in this question what might be the brute force approach. So let's see brute force. What might be the brute force approach? You can see given and sorted array. We have to check using two loops. That is, yeah, two loops. We have to check using two loops, one for outer and one for inner. We will check as they are given. They will be in pairs, so appears exactly once, appears exactly twice. They are given means every element appears exactly twice, only one element which appears single time. So what might be the brute force approach is, we will run two loops. We will check whether I plus 1 is equal to that, or yeah, we will check for int I is equal to 0 to n minus 2, and we'll check whether I is equal to I plus 1. If I is not equal to I plus 1, then obviously that would be the single element. So that would be 2 right here. So that is the brute force approach. Let's now discuss about the modified, like optimized, that is binary search approach. In binary search approach, see if you can see this. Let's write the index 0, 1, 2, 3, 4, 5, 6, 7, and 8. So these are the index. You can see it's an observation based question. Why I'm saying that is, if you observe it clearly, you can see something which you can see with the indexes. See, after certain element, all the elements from its left are odd even pairs. So this is a single element right here. If you check from its left, what will be sorry, what will be the elements appearing from its left? You can see there are odd even pairs. The elements present that is left from left of the single element, all elements will be in odd even, that is even odd pairs. So even index and odd index. Similarly in the right of that, right of the single element, you can see that is odd even pairs. So that is 3 and 4, similarly 5 and 6, and similarly 7 and 8. So this is the observation we have to see right here in this question. So let's discuss about the approach. What the approach is, we will assign that is left, and this is right, and we will divide it. The middle element would be, that is 0 plus 8 by 2, that is 4. This would be the minimum middle element, and we will check whether the middle element is at even index or odd index. If it is at even index, what would we do? So if there are, let's suppose there are no single elements before it. If it is odd element, so no, if it is even element, what we have to check whether the odd element is, if it is even element, we have to check odd that is next to it. For example, this is even element and this is odd element. Let's suppose there are no single elements. If there are no single elements, what we have to do is, even element and even plus one element should be equal, isn't it? So we will check whether 4 and 5 are equal. No, they are not. Then what we have to do is, if it is not equal, we can say the single element will not be present in the right side of the array. So all we can say is, if it is present at 4, there might be some element present before that, which is, that is distorting the pattern, that is odd even odd pattern. So what we'll do is we'll make the right element to the mid, assign the mid here. Similarly, 4 plus 2 is 2. We'll check now 2 element and whether 2 is equal to, so if 2 is what it is, 2 is even, we'll check 2 plus 1 whether it is 3. No, we'll assign right to mid, and so 0 plus 2 is 1, that is this will be mid. We'll check if it is even. So if it is odd, what we have to do is we'll check with its before element. So, yeah, it is even odd pairs, right? So we'll check with its before element. 1 before is 2. If those are equal, what we have to do is we have to assign left pointer to the mid. So here will be the left pointer. And similarly, 1 plus 2 is 3, 3 by 2 is 1. We'll check whether 1 is equal to 2. If it is not, we have to return that 2 index. So see what the let's see the code right here. We will assign like n would be the length of the array, and then what we have to do, we have to assign in left and right pointers. So in left is equal to 0 and in right is equal to n minus 1, and we'll run a loop while l less than r. What we have to do while l less than r, we have to calculate mid element. Mid would be l plus r minus l plus 1. After calculating the mid element, we will check if the mid element is even or odd next. If it is even, what we have to do, if it is odd, what we have to do is, if it is odd, see, if the middle element is odd, that is, let's suppose if it is odd, what we have to do, we have to check its previous element. That is, if there are no elements presented here, see, like this is the, let's suppose this is the middle element and the index present here is 1. So if it is odd element, we have to check its previous element whether they are equal or not. Okay, if they are equal, then we have to assign it's we have to go forward. So that's the approach. We have to go forward using that. And let's see if, and what we have to do is nums of made equal to nums of made minus 1, or mid is at one index, and nums of mid is equal to nums of mid plus 1. What we have to do, simply we have to increase the left pointer to mid plus 1. That's the approach. See, if these two are equal, we have to assign left pointer to mid plus 1, left here, mid here. After it goes to mid plus 1, this would be the middle element. As l less than r, this condition breaks and returns the answer. So that is what I am doing. Nums is equal to mid plus 1, will assign left is equal to mid plus 1, that is mid plus 1. Similarly, else what we have to do, if they are not equal, if this condition distorts, see, if this condition distorts, we have to decrease every time by half, that is right by half, left by half. So that's what I am doing. Else right would be mid. Why I'm doing mid, not mid minus 1? If, see, if you check, if it is present at 1 and 0, if I do mid minus 1, 0 and 0, as this condition breaks, but it is not the middle element, this is the middle element. Or else if we check like left less than or equal to r, or left is equal to r, both condition are same. Why I'm doing extra thing, right? So I'm, when the both the pointers point at a single index, then that would be the answer. So I am doing that. Finally, we have to return either left or right answer, right in element at left or right index. I think this would be the approach. Let's see if it runs. Other errors. Okay, array index 9 out of bound for. Okay, nums of mid plus 1. Yeah, and nums of mid equals to nums of mid plus 1. I think this would run. Why it is showing error? Mid modulo 2 or minus l plus 1. Oh, I am doing this. Yeah, this is the wrong. Why I did that thing, I don't know. But this is the thing. It should be divided by 2. Yeah, now it's running. Submit. Accepted. That's it, guys. Thank you. Okay, if you want to see the code, see here. To subscribe to my channel. Thank you.